Good day, my name is Kesaba Kawan Support. I will be your tutor for mathematics. So today we're going to be learning about what you call limits of accuracy. So when you take measurements, we have different measuring instruments that we're going to be using. So when you take measurements, maybe of time, you use a stopwatch, maybe of length, you use a ruler or anything that measures length. So using all of these measurements, it can create an error. So that's why we say when taking measurements, different instruments are used, and usually collaborating them, they tend to differ, and hence it brings out an error. So these errors, we correct them by using what we call limits of accuracy. So what this topic is really talking about is saying limits of accuracy is giving you a range in which where the true value actually falls. So it's giving you a range of where the true value actually falls. So some of you in your papers, you can see limits of accuracy maybe being described as what you call the upper bound and the lower bound. So limits of accuracy, they give you that true value between the upper bound and the lower bound. That's where the true value is. So firstly, let's go and take an example. An example says, for example, Kabelo measures a length and width of a rectangle to the nearest centimeter. The length is 12 centimeters and the width is 8 centimeters. So our rectangle, we have the length of 12 centimeters and the width of 8 centimeters. And then the question further goes on and says, state the limit of the length and the width. State the limit of the length and the width. So what are you going to do? You're going to state the limits of the upper limits for the length and the upper limits for the width, and then we're going to state the lower limits for the length and the lower limits for the width. So what we are going to do right now is attempt this question. So our length, as we already know, is 12 centimeters and our width is 8 centimeters. So when you are looking for the limit of accuracy, what do? The first step, you find the possible error, which is by considering the next value after the specific value that you're given. For example, your length is 12 centimeters. And the next possible value for 12 centimeters is what? Is 13 centimeters. So what are you going to do? You're going to subtract them. You're going to subtract 13 minus 12 divided by 2 to find the level of accuracy. So 13 minus 12 divided by 2 is going to give you 0.5 centimeters. So this is our level of accuracy. So what are you going to do to find the lower limit? The lower limit, the first thing you're going to do is you subtract this limit of accuracy from the original length, which is going to be 12 minus 0.5 to give you 11.5. Lower limit stroke lower bound. It's one and the same thing. So it's going to give you 11.5 centimeters. So now when you want to get to the upper limit, when you want to get the upper limit or the upper bound, what are you going to do? You are going to add the original length with this 0.5. So it's going to be 12 plus 0.5, which will give us 12.5 centimeters. So we have already found the length, we have found the lower limit and the upper limit. By doing what? By adding and subtracting the accuracy that we're given. And how did I say we find accuracy? You find the next possible value and then you subtract it from the original value and divide by 2. So now let's get on to our width. Our width is 8 centimeters. And what's our next possible error? It's 9 centimeters. So what are you going to do? You're going to do the same thing. 9 centimeters minus 8 centimeters divided by 2, which is going to give you 0.5 centimeters. Nothing changes. The lower limit, what did we say we do? The lower limit or the lower bound, you say our original value minus 0.5, which will give you 17.5 centimeters. And the upper limit, what are you going to do? You're going to add the 0.5. 18 plus 0.5 is going to give you 18.5. So what are these values telling? What are these values telling us? These values are telling us, remember what I said on limits of accuracy, is that it gives us a range in which where the true value actually falls. So this range, when it comes to length, what are we saying? We're saying 11.5 is less than or equal to the original limit, right? The original length, sorry, or it's less than 12.5. What is this statement telling us? The statement is telling us that our true value can be 11.5 or equal to 11.5, but it cannot be below 11.5. And upper, if we go higher, what are we saying? If the value is higher than 11.5, we're saying even though it's higher than 11.5, it cannot be higher than 12.5. So it's less than 12.5. So this says 11.5 is less than or equal to the length, but it is not, it is also less than 12.5. So our range is between 11.5 and 12.5. So when we get to the width, it's still the same thing. We are saying 17.5 centimeters is less than or equal to the width, or is less than 18.5. So this is our limits of accuracy. So just to do a recap in case you did not understand, we are saying limits of accuracy, what do we do? It's different, we take different measurements with different instruments that can end up occurring an error. So what are limits of accuracy doing for us? Limits of accuracy are giving us a range in which the specific value is actually going to fall off. So we have what you call the lower limit and the upper limit. How do you find the lower limit? The first step, you find the next possible value, right? The next possible error, not value. The next possible error in this case was 13. And then you subtract it from the original value and divide by 2. So for the lower limit, you're going to, the value that you find after dividing by 2, you're going to subtract it. And for the upper limit, you're going to add it. Thank you. Good day. My name is Kisawa Kawami Sobozo. I'll be your mathematics tutor. So today we're going to be talking about what we call travel graphs. So what are travel graphs? Travel graphs, these are graphs that are used to represent motion of objects. When you talk of motion of objects, we're talking about how an object moves, at what speed that object moves, at how much distance that object has moved. So motion is movement. The word motion, we mean movement. So this is a topic that you may have covered in physics. So it's maybe, you can say, a repetition. But we also have a maths way of calculating this, a mathematical way. So we have two graphs. We have what we call the distance, displacement, time graph. So what can you say the distance, displacement, time graph is? This is a graph that shows the relationship between distance and time. How distance and time interchange with each other. So when you look at this graph, this is the graph I'm talking about. This is what you call a distance, displacement, time graph. So when you talk about this when you talk about this distance or displacement time graph, this is just a replica of how it is. So in this case, our gradient in this time graph, it represents our speed, how our speed interchanges. So from A to B, there was the speed, maybe you can say it was decreasing, or it was increasing, just dependent on how the question is. From B to C, since you see that the distance is not increasing, that means the speed was constant. And from C to D, it's also the same thing, it represents the speed. So the gradient in your graph represents the speed. So in this case, you are given distance and time, and you can be asked to calculate the speed. What are you going to do? Average speed has a formula that we're going to be calculating with. The average speed, you say, it's equals to the total distance traveled over the total time taken. So these, we're talking about totals only. The average, we're talking about everything, every piece of information here. So for you to find the average speed, you're going to calculate your total distance that you have traveled and your total time that you have taken while traveling. That's how you calculate what you call average speed. Now let's get on to the speed or velocity time graph. What are we talking about when you talk about the speed or velocity time graph? This time graph, it includes a new term that we can say, it's called acceleration. What can we say acceleration is? Acceleration is a rate at which speed changes. So the gradient in this graph now, it no longer represents the speed only, but it represents the rate at which the speed is increasing. How the speed is increasing. If the speed is constant, if the speed is increasing, or if the speed is decreasing. So what are we talking? When we say acceleration, we're not talking about the rate only, the rate of the speed. So our gradient in this case is going to be our rate. So from A to B, you can say your car, and maybe, for example, we're talking about a car, this is a speed velocity time graph for a car. You can say from A to B, your car was accelerating, but from B to C, your car was constant. Why are you saying your car had stopped? Because there was no an increase or a decrease in speed. So it was moving at the same speed. It was constant. It was not accelerating. So as we said, acceleration is an increase or a decrease in the speed. As long as the speed is changing gradually, that's what we call acceleration. So how do you calculate acceleration? Acceleration is equals to the change in speed over the total time taken. So when you get to abbreviations, you can say A is equals to V minus U over T, where your V is your final speed, and where your U is your initial speed, and where your T is your time. So remember one thing, that when you are calculating all of these, you have to use the correct units. You have to use, as you can already see, that my speed is in meters per second. When you write your answer should also be in meters per second. So when it comes to acceleration, acceleration has its own units. Units for acceleration is meters per second squared. Remember what we talked about, what is squared. When we say something is squared, what are we talking about? It's multiplied by itself 2 times. So our units for acceleration is meters per second squared. Even it's the same thing when we come back to distance or displacement time graph. We're talking about the what? Meters, our distance in meters, and our time in seconds. When we get onto the speed, because we said when we calculate speed, you say the total distance over the time. What are you saying? You are saying your values or your units is going to be meters per second. So writing your units is very important, because sometimes a question can come and talk and give you all the values in meters per second, but when it comes to the answer, it wants you to give your answer in kilometers per an hour. So being observant of the units is very important. More especially, you should know what the question wants and if you are using the correct units. Not writing units can cost you marks. So we don't want to be costed marks. So make sure that in each and every question you've written all your units which are available or which were prevailed at that time. So now we can get back onto distance. Your speed velocity time graph can come and say, calculate the distance. How are you going to calculate the distance? The distance is the area under the graph. The area under the graph. You are going to, maybe what I can say is you're going to divide your graph and calculate the area of the shapes that you see there. This is a triangle, and we all know how to calculate the area of a triangle, which is half base times height. This maybe is a rectangle. We know how to calculate the shape. We know how to calculate the area for a rectangle, which is length times width. And this is another triangle. So adding all of these areas the distance that was traveled. So maybe sometimes you don't want to use all of this. You can what? You can calculate the area of a trapezium. So that's how you calculate the distance. When you get back to this side you can only be asked to calculate the speed and being able to see how your graph changes. Being able to notice that from A to B, my speed or my gradient was increasing, which means my speed was also increasing. So in this case, you should be able to interpret your graph and know what your graph is talking about so that you can be able to answer the questions that are prevailed to you. For example, if I can state an example for you, and say, calculate the speed of the body of the graph from 0 to 10 seconds. From, let's say maybe here it's 0, and your 10 falls here, and the 25 falls here, and the last one falls 60. And your 0, 5, 10, 15, 20, 25, and 30. So the question can come and say, calculate the speed of the body of the graph from A, from the first 10 seconds. What are you going to do? What are you going to do from the first 10 seconds? What are you going to do? And remember what we said speed was? Speed is the total distance traveled over the total time taken. And in this case, it doesn't want the average speed, but it only wants the speed. And what are you going to say? Speed is equals to, remember, from 0 to 10, what's your distance there? Your distance is 30. And what is your time taken? Your time taken is 10. And 30 divided by 10 is 3 meters per second. So that's how you're going to calculate your speed, given the values that you are going to be given. This was just a simple example. So this is how the questions are going to be structured. These are how the questions are going to come to you. So you better understand and to know the formula and be able to apply what the formula is saying. There's a difference between what you call just speed and average speed. Average speed is the total for everything that has happened in the graph. But speed, unless it specifies on speed, maybe the first 10 seconds or the first 20 seconds. So speed doesn't cover everything that is on the graph. So I hope you can learn something from that. Thank you.